is a special video on interfacing a temperature device. I have come across students who are struggling to get their temperature device into the computer. So I will just give you an overview and also a practical insight into how to build graphical user interface in Linux operating system as well as in Windows operating system. In both the operating systems, we will be using languages like Qt, which is a C++ toolkit, and also Python. And also in a Linux operating system, using a simple terminal, how to make a plain C++ program, that will also be discussed. Now you can see on the screen, this is temperature devices. This is a temperature device which I have in my hand, which is sold by a company called LAKESHORE, and you can see in channel number 187.5 Kelvin temperature is coming. It's a 8-channel device. So I would like to just read the first channel temperature. Now, in order to interface device, you need to know a lot of things. Also, how to build a GUI, graphical user interface. It's a type of interface that will allow users to interact with electronic devices through graphical icons and visual indicators. Now, building a GUI, the actions in GUI are performed through direct manipulation of graphical elements. It's a type of interface, and GUI can be found in computers, gaming devices, MP3 players, etc. But this GUI is for interfacing a device, getting a data. And one of the languages, open source languages, which we'll use toolkits, is called Qt. And here you have to write the program in C++. So you need to download a program called Qt Creator, and it's an integrated development, nothing but you can create a project out of it, and you can put your C++ files underneath and develop an applications. And now there is a tool under Qt Creator which is called Qt Designer, which can be used to quickly design the screens instead of writing so many lines of program, and then link the screen with a real program to take the data. Now when you buy such a meter, LAKESHORE meter, this is the kind of specifications which is given in their communication manual or serial interfacing manual. It says this is a device, it's a DTE device. What a DTE device is, something which I explained in my earlier video. Anyway, don't worry about that. Right now you think that it's a device which can simply send the data with a specific kind of 9-pin connector. Now what you need to look at in the screen is what is the speed, 9600, that is what I have set it, baud, that is bits per second, and the protocol is 1 start bit, 7 data bits, 1 parity bit, and 1 stop bits, and the parity is odd, so I will call this 9600 071. 9600 is the speed, odd parity, 7 is the number of data bits, then 1 stop bit. And here the terminators are, that means whenever you communicate you have to send a terminator, that means over. I have sent it over, so that over is specified by 2 characters, carriage return and line feed. That's what it says. And the command to communicate, read the first data, is KRDG ? space 1. Now in order to build a Qt environment in Linux, in Ubuntu, you just go and record all these commands, which will be useful to you to download it. Otherwise you can simply take the help of Google to do this. After that, the last 5 commands are basically 5 or 6 commands are basically to create a directory for a project, work directory, and how to make a project out of Qt. Now, in order to create a project in Qt, you have to create a project and choose a Qt widget. And in Qt, you will have 3 types of file: header file h, .h, .cpp, and UI. UI is the user interface. You can see that the user interface, which looks like this on the left side of the screen, and on the right side is the little program which can generate that. So when you start a project, very simple program, and you can see that this is a main program in which there is a Q application class, and you have created an object called app, and another class called Q widget. You created a window as object, and 2-3 lines like this you write, you get a window like this on the left hand side to get started with a GUI. Now if you a little more extend the program in the Qt creator, you will see when you create a project, one main.cpp will be there, then there will be few other files, and there will be a project file, PRO file, under which the files are sitting. At least 3-4 files are required for a project. The main one is main.cpp. You can see the coding. It was exactly like the earlier program. The only thing here, I am creating a label hello. That is what is displayed on the screen. And here the only difference is the label is a class, QLabel is a class, and hello is an object through which I have passed some arguments, and that is being displayed on the screen. Next part of presentation is now just introduction. What is RS232? Because this device is an RS232 device, and how to connect the device, and nowadays laptops don't have RS232 port, they have a USB port, but the communication is through RS232, so you have to have a USB to RS232 converter. And then first part I will explain how to read simply through C++, then again embed the C++ into a graphical interface Qt, then in Python, then in LabView. So this is how the device looks like. Now you are wondering how to connect to the laptop. So this is the kind of connection you need. If it is a Windows system, you can see is a Windows PC with a Moxa driver. Moxa is nothing but a USB to RS232 converter. You have to make a cable between the Moxa converter and the device. That's a 3-wire cable, which I will call this Null modem cable. I will also call it DT cable. You will come to know what it is. This is how the back panel looks like. The 9-pin D connector is the RS232 connector. You will make a cable and you will connect it to the adapter, then connect it to the PC. The cable looks like that. This can be made at home. You can see in the screen the last one, this 9 to 9 pin null modem cable is made like this. You simply need, in fact you don't need all these 5 wires, but you keep this, but you probably need 2, 3 and 5 on the left hand side, and right hand side also 2, 3 and 5. This 3 wire only required usually. And this is how you get started with the C++ programming for interfacing. So you open a Linux terminal and create a file called a demo.c, in which you simply write like this. You are keeping a serial.h, and you are using a class called a linserial, which is specifically coming for serial interfacing. It's freely available. You can see it in Google and download this. This is class library which is available. Many people have used it. Somebody has already written this. So LinCDL is a class, J is an object. You can see on the screen. This is the third, fourth line. After that, using that j.open device, you can, in Linux, everything is a file. Whether it is a serial port or any port, it's a file. So first you should learn how to interface, write a program to rewrite a file. So I am creating a file called yo.txt, and this many lines of program, when you execute, when you say g++ demo.c, you will get a .out. You can execute that. So inside the file, if you see, after executing this program, you will see it will create a new file called yo.txt. Inside that you will find some message yo, dot. This you can find. Now same concept, how do you apply to read and write into a file? I mean RS232 port. So RS232 port is a file called /dev/cua0. Sometimes they are also called /dev/tty/s0. So now it is like COM1 in Windows, and you can LinCDL, you can create an object called m. Then you can set all the parameters of the speed, protocol, everything. So now file *h, you create a handle for the file. After that, printf-dh, that means you are simply writing a string called atz. That means you are sending atz through the serial line, and also you are sending another command atdt1 something to. So that means when you execute this program, atz and all the at commands will go straight through the serial wire and will go and dump into the device. This is a sample program. This is not for the exactly temperature. Meter will have instead of atz some other command. So the command is krdg !1, which I explained to you earlier. Now see, if you want to really communicate with that temperature device, what you need to do is you have to write a program like this in a symbol. You can use a gedit and create a text file in which you can create a test.c, in which you will see after the main, you can see S is the place where you will store the characters. You are creating a LinCDL on object star through a pointer. So in creating a pointer object or normal object, it is similar thing. Now you are accessing through the arrow mark. Now you are opening the device. Then after that it prints opened. After that you are setting the protocol set 701, that was the protocol of the LAKESHORE. Speed you set, and again few things. Next, the sixth line is most important. You are writing the command, you are sending a command krdg !1 /r and /n is like a over, enter. That means over, I am sending it. I send it. After that, just dummy printf I am printing on the screen to get a delay. After that, I am reading from the port. The port to reading from the port is very simple. I have scanf dh, %s is a string, and you are reading into the s buffer. After that, you will see the temperature trapped, like you can see at the bottom, +480K is trapped by this program. Now same thing, if you want to build in a user interface, graphical user interface, you have to embed that program into Qt. Qt environment looks like that. When you start your Qt creator, you can create a project like this, and in a widget you can simply put a button, read T from L meter. So what you need to do is, whatever program we explained earlier, C++ program, now you have to embed into this button. That's all. Now how do you do that? So you have to write this program. This is one of the files only you need to edit. That is, you must have created in Qt, there is a way to call a function called slot 1, in which you have to embed the C code which was already created earlier. So you can see at the bottom of the screen there is a last function, that is void main window double colon slot 1. That is where you write. That means when you press a button, this function will be called. The exactly same function which was written earlier in the terminal, I have just copied into this. Here I said, here the device right now I use is TTY USB 0 because it's a USB device. USB adapter I am using, and I am, instead of displaying in a graphical user interface, you will be displaying in a message box rather than simple characters on terminal. So you are having a ready-made object called message box out of the ready-made class Q message box. And next, see, you continue with this. This is the slot program which you are defined inside the Qt environment. Same program which I was showing you to you earlier. Cut and pasted that. This KRDG question mark space 1 I have put in this. So after this, if there is a way to compile this program, after compiling you will see that the Qt will create a graphical user interface which looks like that. You click on that read T from L-meter, that means slot 1 will get executed. The first line which was written in the slot 1, if you can see that it was like, you can see that port opened, that is the fourth line. So that has come here. Now protocol being sent, that was, you can see that it was here, that is 1 2 3 4 5 6 7 seventh line. See, seventh line after means after the slot 1. After that there are some commands which are supposed to be port opened. All these things are coming from that program. After that, last line is basically I have read the temperature. It has come in a graphical user interface. Earlier it was coming in a terminal. Now how do you interface an RS232 temperature device reading data using Python? How do you do that? Same thing, same setup, same hardware setup. You use the same adapter, same cable. You can simply write a program like this. You can simply, I have used Python 2.7.13, and so one of the older versions. Okay, that's okay, fine. You can simply use import serial, that is the library of that. You can simply set the protocol parameters in that. After that, you can see, if you go through the line, you can see that input is equal to KRDG question mark 1, that is command being sent, and after that you simply send the command. There is a while loop which is at the end, while serial dot in waiting greater than 0. That means whenever character has come back, the return reply, it will collect one by one into the out variable. So you can see this is what it is displaying every second, because in the program I said while 1 means, and time dot sleep 1 I have put, that means every second this loop will execute infinitely. You can see that the Python program is working. This can be tried out in Linux and Windows. If you want to further extend the GUI functionality in Python, you have to simply put into a message box like earlier we were doing in a Qt. Now the other most popular, if you want to do same thing in Windows, one of the most popular tool is LabView. You download your version of LabView free for 1 month. You can try this program. So the best way is go to help and find examples inside the LabView. In the LabView, when you open this main screen, top you will see help. There you go to find examples. There is a menu. From there you just download a program called find simple serial.va. This program will come into the screen, in front of you. So the only thing is the command which has to be sent, KRDG/s question mark 1, will not be there in that. You have to edit that. So this program basically is configuring your parameters, and you are sending a command through visa write, and wait for some time. Then when characters are available, it reads back, gets the result in response. Now the interface, it looks like that. This is behind the scene was the program which I shown you earlier, and all these buttons are all here, which was only you are seeing here also same thing, because when you do a Control E in Windows, you can switch back and forth between these two windows. See, when you execute this through that arrow mark key on the left hand side, run it once, it will read the effective output response as plus 471.89 characters. So details of all these examples are available in this book. This book is very specially written only for interfacing purpose, and this can be bought online, and this will cover a large number of topics. One of the basic topics is what I explained in this video. Thank you.